Video, I'm going to show to you how to solve this Rankine cycle here. With at point 1, we have a given of 2.032 MPa with a temperature of 232 degrees Celsius. At point 2, we have a given of 1.572 MPa. At point 3, we have a given of 1.061 MPa. At point 4, we have a given of 533 kPa. At point 6, we have a given of 227 kPa. And point 7, we have a given of 54 kPa. Whereas to find the TS diagram, the mass 2, mass 3, and mass 6, work turbine 1 to 2, work turbine 2 to 3, and so forth. So we have to find the TS diagram. We have done drawing this TS diagram in the blackboard. So let's proceed to the point 1. At point 1, we have a given of pressure 2.032 MPa with a temperature of 232 degrees Celsius. Since these two givens is not found in the steam table, we have to use this process. Pressure is pressure 2 MPa with the middle of a known pressure of 2.032 and pressure 2.05 MPa. In the steam table, we have the given temperature of 230 with the middle unknown temperature. The steam table 232 and 235 degrees Celsius. Whereas to find this entropy and enthalpy, so the equation is 232 degrees Celsius minus 230 in this pressure. We have to solve first the enthalpy. So let's simply substitute all the givens. 2849.6. Substitute this to the temperature 230 and copy this to the bottom, and 235 enthalpy in this, copy this to the bottom, and the answer of this equation H2 H2.00 is equal to 2855.4. The same process in this specific entropy. We have to solve this specific entropy. So the answer is 6.45302, and this, the left side, this enthalpy given, we have to simply substitute also. So we have the answer 2852.58, same as this specific entropy. We have the answer of 6.43754. We have, so since we have the all given, the given enthalpy and entropy of these two pressure, so we can solve this unknown enthalpy and specific entropy. So the same process, the previous this. So we have the answer of 2853.4016, and the specific entropy is equal to 6.4431. So let's proceed to the point 2. Point 2, we have the given pressure of 1.552 MPa with the specific entropy is equal to specific entropy 2.
What we do here is go back.
Since we have an given specific entropy, whereas to find the enthalpy, the same process of this point 1 in this point 1 to find the enthalpy. So we have the answer of enthalpy 2, 2800.65. So let's proceed to the point 3. At point 3, we have the given pressure 1.061 MPa. The same also at point 1, point 1, point 2. The specific entropy is equal to S1, S2, S3. So at the steam table, we have the known value. Since this S1, S2, S3 is, whereas to find the quality X, so substitute the specific entropy 6.4431 with the SF of this. Have solved this the same process, we have the answer of 2.6 2.1632 plus x na unknown times this SFG, this is equal to 0.97. Since we have the specific variety x, to solve the x, so we have to use this equation. H3 is equal to HF plus X HFG. So let's simply substitute this SFG plus substitute this X and SFG. So we have the answer of enthalpy of 2724.57 578. So let's proceed to the point 4. So we have the given pressure of 533 ppa with the same specific entropy of 0.1, 2, 3 and 4. So this process is the same at point 3, whereas to find the SFG, SF, HF and enthalpy FG. So the same process to find, substitute all the givens at the same table. So S1 is equal to S4. Copy this, substitute this, and we have a HF of 1.88,516 plus the variety X times the specific entropy FG, 4.91,465. Substitute also, and we have the answer of X is equal to 0.927 or 92.7%. So the same, substitute this to find the enthalpy. SFG, substitute this plus the X value times the enthalpy HG, this. So we have the answer of 2597.6. At point 5, we have a given pressure of 533 kPa and temperature of 1.73. So this process To solve this, point 5 is the same process at point 1. So substitute all the givens in the same table. You have the answer of this enthalpy, this entropy at the left side, and this entropy of the right side, and we have the middle pressure 533 H5 is equal to 2794.78, and the specific entropy is equal to 6.90457. So let's proceed to the point 6. At point 6, we have the given value, the given pressure of 227 kPa with a specific entropy of 6.90457. So the same process, the point 3 and point 4. So this, substitute this, we have the H6 of 2640.14. So let's proceed to the point 7. We have the given pressure of 54 kPa. The specific entropy 5 is equal to specific entropy 6 is equal to specific entropy 7. So the same process again at point 3, point 6, and point 7. So we have the answer of 2412.1. So let's proceed to the point 8. At point 8, since we don't have the given equation, the given, so we have to solve this H8. H8 is equal to HF at pressure 7. H8 at pressure 7. HF at pressure 7. This HF at pressure 7. So we have 348.53. To solve this work pump 1, so we have to find the V value. 0.055 minus 0.0550 is equal, divided by 0.054 minus 0.050 is equal to 1.316 minus 1.0300. V minus 1.0300 V. So we have a V given 1.03128. So since we have a the V value. So we have to find this work done of the pipe one, pump 1. V is equal to pressure 9 minus pressure 8. So simply substitute the V value times the pressure 9 to 277 minus 54. Pressure 9 is pressure 9. Pressure 9? Pressure 9. So we have the work pump 0.1784 kilojoules divided by kilogram. At point 9, we have the work pump is equal to H9 minus H8. So simply substitute this 0.1784 minus H9, then substitute this H8. So we have the answer H9, the enthalpy 9 of 348.7000.84. So let's proceed to point 10. At point 10, the same process also at point 8. Same process of this point 8. So we have the work pump to 1.50 1.5074. The same process at point 9. We have enthalpy 11 523.4774. So let's proceed to the point 12. Point 12. There you are. So we have point 12. H12 is equal to HF at pressure 3. So the HF of the pressure 3 is equal to enthalpy 12 na 774.36. So let's proceed to the point 13. Point 13, we have the HF at point 12. Point 2. So the same process. So we have the answer enthalpy 13 of 854.94. At point 14, we have the enthalpy 14 is equal to HF at pressure 3. So the H14 is equal to H15. So the H14 is equal to 774.36. So let's proceed to the point 15. Since the H14 and H15 is equal, so the answer is equal also. So let's proceed to point 16. The HF at pressure 2 is equal to enthalpy 16 is equal to 854.94. At point 17, the same also, or equal this to H17 is equal to 854.94. So we have all the givens, all the enthalpy 1 to 617. So let's proceed to find the mass. So the enthalpy 2, this is the equation of this mass 2. At mass 2 and so we have to use this this equation. Enthalpy 2 times mass 2 plus H12 is equal to H13 plus H16 mass 2 times mass 2. So substitute all the givens. So we have mass 2 of 0.04. So we have to find the mass 3. To find the mass 3, we have to use this equation. H3 mass 3 plus 11, because 11 is the right side, to the H12 is equal to H14 mass 3 plus H12. H14 mass 3 and H12. So substitute all the givens. Enthalpy. So we have the mass 3 is equal to 0.13. The same also as the previous. So page 6, since this is page 6 mass 6 plus H17 mass 2 plus H9 minus H9 mass 2 and H9 mass 6 is equal to H10, because the H9 is 1 minus mass 2 minus mass 6. So substitute all the givens. So we have the mass 6 is equal to 0.07. And lastly, we have to add all the masses. So substitute all the masses and we have the total mass of 0.24. So let's proceed to the last process. We have to find all the work done. So this is all the work done of the turbine. So that substitute also the given. We have the work turbine 2 is equal to 52.75 kilojoules kilogram. Substitute all the work turbine 3. We have the 1 minus mass 2 times H2 minus H3. So substitute all the givens. So we have the answer of 73.03 kilojoules kilogram. Work turbine 3. The work turbine 4, 1 minus mass 2 minus mass 3 times the enthalpy 3 minus enthalpy 4. So substitute all the givens. So we have the work turbine 4, 105.4 kilojoules per kilogram. So the same also at work turbine 6. We have 1 minus mass 2 minus mass 3 times the H5 minus H6. So substitute all the given, and where we have the work turbine 6 of 128.35, and then work turbine 7 at 6 we have 1 minus mass 2 minus mass 3 minus mass 6 times the enthalpy 6 minus enthalpy 7.
What we do here is
So
go back,
substitute
back,
also.
back.
So we have the 100. We have the work turbine 7, 173.31. So work pump 1. We have 1.1 minus mass 2 minus mass 6 times work pump 1. Substitute also. We have a work pump of 0.1588 kilojoules per kilogram. We have the work pump 2 is equal 1 times the work pump 2 is equal to 1.507 work pump 2. So let's proceed to find the heat rejected and heat out. Heat A13, we have H1 minus H13. We have to substitute also. We have the answer of heat 13 of 1998.46 kilojoules per kilogram. Heat 5 is equal to 1 minus mass 12 minus mass 3 H5 minus H4. So substitute also all the givens. So we have the answer of 163.66. The work total, so add this to heat total, sorry. So substitute all this heat 13, heat 5. So we have the answer of 2162.12. So we have all the given. So since we have all the givens, whereas to find the last, we has to find the end for ideal cycle. We have the work net or the work total minus the work pump. So substitute the work total of 532.84 minus the work pump has 1.6658 and the heat total of 2,862.12. So we have the end total for the ideal cycle. Answer is 0.25 or 25%. So thank you for all. Thank you for the all. I hope you have learned just a little. So that's all. Thank you.